Hi all. Basically just trying a slightly more complex example of graphing cos or sine functions with transformations. In this case we have a cosine function that's been inverted with other transformations, and we're graphing it from minus pi to pi. Hopefully you'll see though it's pretty much the same process, it's just there's some extra steps along the way because it's not as nice an example as the one before. So what we'll do first is basically I want to just draw a basic example of the graph that we'd have. So here we have not just a cosine function, but we have one that's flipped. And so that would kind of look like this essentially. Okay, maybe I'll bring that down just a bit. But essentially this is going to be after, again, we'll go period, so that is p. And so this is after one period, this is half a period. It hits a 0 at a quarter of a period. It hits a 0 again at 3/4 of a period. And actually, to be more specific, because we are going to translate this thing, it hits the midpoint at those points. The maximum value is here, and the minimum value is here. All right, so now what we're going to do is basically we're going to, actually we'll consider some of the facts. So in this case here, what used to be our origin, okay, so if we have our origin here, which was 0, 0, our transformed origin, because it's been dragged to the right by pi on 3 and up by root 3, that transformed origin is going to be pi on 3 root 3. So I don't have the axis drawn yet. Basically, it's been moved to the right and up. Now, what else? Let's maybe draw the axis in first. So I'll just quickly pop that in like so. Okay. So essentially what we're expecting is that there will be some sort of central point which has been shifted. So from the origin here, it's been moved to pi on 3 root 3. So I'll just say that's about there. Okay. But something to keep in mind in this example is that we don't actually, our graph isn't going to actually start at this point. That's just our origin. Because for example here, even though that's our origin, the graph actually starts down here. It starts at the minimum value. So now let's just figure out what those minimum, maximum values are, etc. So first thing I'm going to do is I'm going to find the amplitude. So the amplitude for this graph is 2. It's just the positive version of whatever that coefficient is. The middle value is going to be based on this, how high that origin has been brought up. And so the origin has been brought up by root 3. So the middle value is at y equals root 3. The max value is going to be the amplitude plus that. So it's going to be root 3 plus 2. The minimum value is going to be root 3 minus 2. And so if I just quickly draw those, now that's why it is useful to know what root 3 is roughly, because root 3 is roughly, I might even just write that here. So that's roughly about, don't remember exactly, but it's around 1.7. So that means that when we have root 3 minus 2, that's going to end up in the negative section. So it's just a good idea to roughly know where those sort of things are. Now let's just basically draw in those points. So we've got y equals root 3 here. We'll go y equals to root 3 plus 2. And then about here, so that's y equals to root 3 minus 2. And I might just shift that just slightly up. Okay. So once we've done that, then we're going to basically consider where our values are going to be. So at the origin here, which has now been moved to this point here, we expect that there should be a minimum value there. So it means that we are going to have our graph down here. So our first plot is actually going to be down here. After that, and then after that, we're going to move across basically as before. We're going to move every quarter of a period and then just plot those different points. So let's just figure out what that is. So in this case, the period is going to be 2 pi divided by that coefficient, which is 2. So it's 2 pi divided by 2, which is pi. It doesn't always have to be pi. That was just basically because the previous example was that too. So it's more of a coincidence. But essentially that's that. So that means, maybe so I'll just write it out. A quarter of a period is going to be pi on 4. And something that we're actually going to do, I should have probably labeled this. This is, we're starting from pi on 3 over here. And so because we're going to be basically adding or subtracting pi on 4 each time, because we're going to be going a quarter of a period across, we're going to be basically doing a lot of addition and subtraction. So it's nice to have these sort of just in the back of our mind. So if we're going to be adding pi on 3 and pi on 4 together, it's good to have them with the same denominator. So just keep in mind that pi on 3 is the same as 4 pi on 12, and pi on 4 is the same as 3 pi on 12. And so as we're going along, we'll be able to just sort of fill that in. And for the sake of this, I'm also not going to simplify the fractions, but we'll basically just see how that looks. So in fact, what I might do is I'm just going to change this to 4 pi on 12 now. Okay. So after this, we're going to move 1/4 of a period to the right now to figure out our next point. So 1/4 of a period after, that's going to be 4 pi on 12 plus 3 pi on 12, which is 7 pi on 12. And so that's going to put us now at, let's see, after a quarter of a period, we're going to be at the midpoint. So we're going to be up here. And then a quarter of a period after that, we're going to be at the max point, because basically a quarter of a period after that is up here. And I'm just going to basically just keep repeating that process. So I'll write it here just so you can keep track of that. But essentially we got 10 pi and 12 now, and then we're going to go another, actually we can't go another step after, because if we were to add another 3 pi and 12, what we'll see is that we're actually past the endpoint that we're looking for. So this is going to be the highest point. This is going to be the furthest point that we can do in terms of a whole quarter period. So now after that, we need to just try and figure out, it's going to end basically, what we can tell is that it's going to end somewhere in between here, wherever that is. And so what's something that we can do there is basically we can find out what that endpoint is going to be. So I'm just going to do a bit of a substitution. So what we know is that when x equals to pi, that's going to be our endpoint. We want to try and figure out what the value of y is going to be. So that's going to be minus 2 cos 2 pi minus pi on 3. It is a bit messy, plus root 3. And then if I'm just going to skip a few steps here. Let's see what we can do. So that's going to be 2 pi on 3, 4 pi on 3. So, and sometimes it is useful to draw the unit circle. So you can just sort of visualize that. So 4 pi on 3, that's going to take me basically to over here. The cosine value is going to be negative there. And basing off my exact values, I'm going to know that's going to be minus 1/2. So basically that is going to be minus 2 times minus 1/2 plus root 3. I am skipping steps here, which gives me 1 plus root 3. So essentially I know that this is going to end maybe around here, where I have essentially a known point. This is going to be at pi, 1 plus root 3. Now, something that you can do basically to save a bit of time is that we actually, because we know the period of this case, in this case is pi, every pi period is going to end up back at the same place. So we actually do know that roughly, if this is pi, then at 0, it's going to be also at 1 plus root 3. And then at minus pi, it's going to be at 1 plus root 3. That's just a trick that we could do if we wanted to. And it just happens because this period is pi. So I might do that just to save myself some time for substitution. So we'll do that. So 0, 1 plus root 3. And then minus pi, 1 plus root 3. Okay. Now, what we've done here is we filled in basically the positive sections here of this graph. And so the next thing that we want to do is basically figure out what the negative sections are going to be. And so what's happening here is that we know we're going from 4 pi and 12, and we're going to go backwards a quarter of a period. So that's backwards pi and 4, or 3 pi and 12. And so that's going to be, let's see, pi on 12 here. And at pi and 12, basically, if we were to go backwards, we're going from the minimum, we'd be going back up to the mid. So the midpoint here. So we know that this point here should be up there. And then a quarter of a period behind again, so that's going to be, what's it, pi and 12 minus 3 pi and 12. So that's going to be, what's that, minus 2 pi and 12. And that's going to put us at the peak. And basically, as you're going with this, by the way, you can skip steps. I'm just sort of going through these bit by bit. And then after that, that's going to, another set, that's going to be minus 5 pi and 12. That's going to take us back to the midpoint. Minus 8 pi and 12. That's going to take us down to over here. And then minus 11 pi and 12. That's going to take us back up here. And so I think from what I can see that 8 pi and 12 should also be a bit to the side. So let me just shift that across a bit. Oh. Okay. Yeah, and then that's pretty much your shape. And so then once you have that, you can basically just fill in the graph. And so what we have here, I'm just going to extend that. So we're going to go from here, go up to that. Here I'm going to go basically to the top like that. And the shape's not too great. It's a bit wonky here. If I were to do it, maybe we'll redo that part. Oh. Okay. And then this part here, that's going to go down to there. This part goes to here. That part goes to there. And then that's pretty much our graph. The only things, again, are the x-intercepts. I am going to skip it again just for the sake of time, but basically what you would do is you solve for when y equals 0, because we want to know when it's at that height there. So you would be solving the equation for your x-intercepts. And whatever the solutions are, that's basically going to be your points. Here, 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 and there. Okay. So yeah, let me know if you have any questions. Otherwise, that's generally the process for graphing sine or cosine graphs with transformations. Okay, thank you so much for listening.